So, hello members. In our discussion today, we are using finite differences to determine the equation of the polynomial that gave the corresponding values of the polynomial at each of the x values. So we are having x and we are having y, meaning y is representing the polynomial of x. And so at each value of x, we gave y. But now this is the data given to us, and we have to work backwards to find the equation of this polynomial. And through the finite differences, we shall be able to determine the degree of the polynomial, and from there we can establish what the polynomial is going to look like. And from there, we find the values of the coefficients, and later on write our polynomial. So let's write our start. So now we are given this table of values, and we shall redraw our table and put our differences. So we have the first difference, the second difference, the third difference. So we are saying the first difference of f of x. Okay, if we say the polynomial of x is the same as the function of x. So we are taking the first difference of f of x, the second difference of f of x, the third difference of f of x. So that means I'm going to be saying I have this y, okay, which represents f of x, okay, and from there I have y1, I have y2. So the difference here will be saying y2 minus y1. So that's what I'm going to be doing. I get 20 minus 75, I write here. So 20 minus 75, I'm going to write it down here. So this is going to be negative 55. So what next? I get 1 minus 20, I get negative 19. Then I get this 0 minus 1, I get negative 1. Negative 1 minus 0, I get negative 1. Then negative 20 minus that, I'll obviously have negative 19. And also the last one, negative 75 minus negative 20, I get negative 55. So the second difference here is going to be I get this minus that. So negative 19, I'll have negative 19 minus 55. So what does that become? I'm going to be having 36. So 36, remember I'm writing down here. So 36, I get negative 1 minus negative 19. I'm having, okay, 18. The negative 1 minus 1 minus negative 1, I'm having 0. Then negative 19 minus that, I get negative 19. I mean negative 18. So negative 55 minus that, I get negative 36. Then I proceed. Because why do I proceed? It's the fact that if I get the differences and they are not constants, I keep proceeding until a time when all these values under the difference column are constant. So what I'm going to do, I proceed with 18 minus that, I get negative 18. 0 minus 18, I get negative 18. Negative 18 minus 0, I get negative 18. Negative 36 minus negative 18, I get negative 18. If I proceed, the fourth difference would be 0, because it is going to be this minus that. This minus that, I get 0. This minus that, I get 0. This minus that, I get 0. But now, how do I get the degree of the polynomial? Degree of the polynomial is going to be 3. is equal to 3. Why? Because it's the third difference, okay? The third differences are giving a constant value that is non-zero. So because third differences are giving a constant value, okay, that is non-zero. So in other words, these zeros are also constant, but they are zeros. So we cannot say that this data was obtained from a polynomial of degree 4 because these values are zero. But we can say they were obtained from a polynomial of degree 3 because the third differences are giving us a constant value that is non-zero. And therefore, we can say our polynomial is going to be f of x, which is equal to ax cubed plus bx squared plus cx plus d. And that is going to be the polynomial format that gave these values, because we are saying it is of degree 3. If it was of degree 4, then f of x would have been ax to the power 4 plus bx cubed plus cx squared plus d plus f maybe, okay? And then you proceed. But our polynomial that we are having is of degree 3. So we are going to take that polynomial and now look for the values of a, the values of b, the values of c, the value of d. So what are a, b, c, d? So how do we proceed? Now we are going to record this formula of a n factorial, okay, equal to the third difference. But now this formula works only and only if the change in x, or what we call the step size h, is equal to 1. Okay? Others can say actually it is 6a h squared equal to sigma, or the third difference. Okay? The third difference. So what is h here? When we look at our data, there is a difference of 1. Okay? There is a difference of 1 from 3 to negative 3 to negative 2. There is a space of 1. From 0 to 1, you see there is a space of a step size of 1. So that means if my third difference is negative 18 is a constant value, therefore I will have 6a times 1, which is squared, is equal to, what value is that? Negative 18. So I'll have 6a equal to negative 18 divided by 6 divided by 6, and my a is equal to negative 3. So my a is equal to negative 3. What does that mean? That my f of x is therefore equal to negative 3x squared plus bx plus c, or 3x cubed bx squared cx plus d. Now what we can do is to start substituting in values. Okay, we can put in values there and then be able to determine maybe what is the value of d, what is the value of b, what is the value of c. If I put in from 0, okay, I'm going to say at x is equal to 0, at x is equal to 0, what is f of x? F of x, we have seen that is also equal to 0 according to the information that we have. Okay, so that means I'm going to put in here, so my 0 is going to be obviously 0 plus 0 plus 0 plus d, meaning that our d is equal to 0. So that is the first unknown that we have obtained. We had a, and now we have determined d, so we go ahead to look for b and c. So let us put we are going to use negative 1 and 1, then 1 and negative 1. So at x equal to 1, f of x is equal to negative 1. And therefore, if we substitute in here, it's going to be negative 3, okay, into x, which is 1 power 3, plus b, which is 1 times the, 1 squared, plus c into 1, plus d, which is 0. Everything is equal to negative 1. So that means we will have negative 3 plus b plus c is equal to negative 1, meaning that b is equal to negative 1 plus 3 minus c, and therefore my b is equal to 2 minus c. I call this equation 1, okay, and proceed. We proceed to a point where we have x is equal to negative 1, our f of x is equal to 1, as we have already seen. Okay, if x is equal to negative 1, then f of x is equal to 1. So what do? We substitute in those values, and what are we going to get? We are going to put negative 3 into negative 1 cubed plus b into negative 1 squared plus c into negative 1 plus 0 is equal to 1. So this is going to be negative 1 cubed is negative 1 times 3, that times negative 3, that becomes 3. So plus b minus c is equal to 1. So my b, okay, already from the first equation, I have it, okay. So that tells us that our b minus c is equal to 1, okay, minus 3, and this is equal to negative 2. Now what do? So from this equation, this is equation 2. So from equation 1, we see that if we substitute in our b here, this b is already 2 minus c, okay, 2 minus c, then minus c. Obviously, this is equal to negative, this is equal to negative 2. So what do? We see that negative 2c is equal to negative 4. So our c is equal to 2. So finally, the polynomial f of x equal to our polynomial p of x is going to be negative 3x squared plus b. Do we know b? So if c is equal to 2, okay, if c is equal to 2, then what is b? So our b is equal to 2 minus 2, and that is equal to 0 according to equation 1. Therefore, our f of x will be negative 3x cubed, okay, plus b, which is 0, so we shall not take it. So plus 2x, then plus 0, and then that is going to be our polynomial. If you want to test it, you can test it by putting in values. So putting the values may be that we have not used. For example, at x is equal to 2, f of x is equal to negative 20. So let us test our polynomial. So f of 2, what is it going to be? We have negative 3 into 2 cubed plus 2 into 2. This is going to be, this is 8, okay? This is 8 times that is negative 24 plus 4. Does it give us negative 20? Yes, because if we substitute in, it gives us negative 20, and that is the value of the polynomial of x that we have in our data. And therefore, it tells us that our function is actually right. Thank you.